So, hello everyone, myself Sahil Kumar Singh. I am a BTech third year student in NIT Allahabad. So basically today I am making this video to demonstrate my RAG system. I am using a model from Olama and so as to prevent a context plot, I have created this RAG system. Let me show you. So, if you guys have ever used Olama, you know that we can run local models. So here this Quen 2.5 order of Quen 2.5 instruct model. So let's go with this one. So you can talk to a local model, but let's say hello. Here start to generate answer. We don't require any internet. Necessary it can write a code. Okay, all that is good, but when you want to work on some PDF and provide that PDF to it, it really don't have that level of context size, and sometimes it start to hallucinate on larger context. So as to prevent that, we have created a RAG model which feed all the PDF to a RAG system, and when you ask your query, only the relevant part of the PDF fetch and provided to a model which prevent a context plot. Okay, so yeah, it's working fine on locally. Okay, you can see this. Yeah, all right. So this is how it can generate locally. Let us don't waste our time on this. So we can also do, so here is my rack system. What we can do, we can upload files, whatever we want. Once it's uploaded, we do a semantic based searching. Okay. So let's say we can select a PDF, whatever we want to search for, and let us search some meaning online. It's not required. I'm just showing you how semantic search works. So let us take a definition. If we only copy a definition, there's no mention of RPC, right? But if we want to ask, first of all, our RAG system fetch some documents, and if we see the documents, we can clearly see it has fetched all documents and chunks related to RPC. How does it know we are talking about RPC? And if you even see, you may find somewhere stub also. Save procedure generate, yeah, client and server stuff. Yeah, in the PDF there's no mention of stub other than this, but it's working fine. And once a model get that information, even it's not complete, but model get an idea, and model is smart enough to fill those gaps and answer our questions. So okay, I will mainly fast forward these things. This is how our RAG system works. But let us try to ask the same question when we are not using a RAG. And let's see, and let's refresh it. And let's see what kind of output we get. Look, it's not able to know that. That's very difficult for them to just understand what we are asking. But with the help of RAG, we can do this efficiently. Okay, this is all. let us see the code. So basically in code part, what we have done is, hmm, so basically we have written a modular code. So if you see here, like so yeah, this is the backend side. So here's the main which defines some of the endpoints. So when you call upload, it takes a file from the front end, upload it, and what it does, here it come to a document loader which loads the file content in form of text and images. And for images we are using a tesseract, which is basically a OCR, so optical character reader. Basically what it does, it reads the characters from the image and convert it back to text. So at the final result we only get chunks of text, each divided based on each page. Okay, once we get the chunk, we further divide chunk based on the context size of our embedding model that we are doing in the chunking mode, chunking pipeline. So here document chunker. So what does document chunkers do? We have defined like 1,000 words, 1,000 character limit. Okay, so it do not allow more than 1,000 characters to be in a chunk. So it process sentence by sentence and see if we add that sentence, is our limit reaching or not. If it does, we do not. If it does, we do not add that sentence and create a chunk from it. That's all. Once all the chunks are created, we are doing one more thing, which is making our rack system much more efficient. We are actually doing a coreference resolution. What it does, basically, in a chunk there are so many pronouns, and pronouns actually refer to some of the nouns which may be in other chunks. And since each chunks are broken, dependency to other chunks may lead to like ambiguity, and we cannot get what it is referring to. So as to solve those references, we are doing this coreference resolution. So we are basically using spacing. So it's a library which finds subject, object, noun, pronoun, what kind of token it is. Okay, based on which if we get any preposition, we are changing it to like the last active noun known to us, and that's how it works. Yeah, it's not accurate, but even if it's inaccurate, a model can still understand. We are creating these chunks, and finally we are feeding this to model by a RAG system, and model is smart enough to understand those errors. Okay, so it works well. Without this, model may not know what we are talking to with the references of pronoun. Okay, so this is all, and that's it. We have chroma database. We are using cosine similarity here, because earlier we were using that default similarity which was there in that chroma db, which is like square distance L2, but it was not so efficient. Now when we have switched to cosine, it's working really well. Okay, and you can read that uh, code if you want. It is on GitHub, and front end it's simple. Yeah, but yeah, we have created some of the things in front end. If you want to see it, let me show you. Like okay guys, just for a second. So one of my friend was there. Yeah, so I did some work on front end as well, so as to like write code and for latex like math expressions. Let me show you. So can you write, let me provide some context as well. So we are using the same model like one we you have seen on like command prompt. Yeah, here you can see like on the second line. Yeah, it's a code. MPI and socket. Even this one is a code. Function has following int. Okay, let us wait for model to write it. What is this? Read timeout. That's not good. It's happening. Yeah, so it took a lot of time. That's why it's not looking. So let us try again. Mm, what might be happening? Mama is working. Let's do this again. Let's see what's happening. Mm, yeah, the context is provided. Let's see. Yeah, it start writing. Sure, here's the code. I think I didn't write that it need to provide it in C. So as you can see, all the code it write, it comes in a code block automatically on the front end side. You may copy this code and use it anywhere you want. It's working really slow, maybe because I'm recording myself on OBS and it is consuming a lot of processor. Okay, here it is. Okay, let us refresh it so as to reduce the context size, and let me ask it to, can you write some check expressions also like let's matrix expressions. Let's see, since we are using a latex it should work. Yeah, it's working really slow. Let me, I cannot. Okay, square variable. At this point I would have just turned off the OBS, but I can't do that. Don't worry guys, for you I will like speed up this video part. Whatever, it's taking a lot of time. I hope it will not start. And yeah, here comes matrix expression. Let's see. P matrix. I'm expecting a lot from it. Wow, just see that latex expression. Even though I'm not involved in it, basically I'm using a library which is converting it to HTML format, but it's okay. It's fascinating to see this. So you might be wondering if it really worked that slow, but no, it isn't. If you see my task manager, you may get the idea why it's working so slow. Like 100% CPU use. Olama, but it's not the only thing that is consuming a CPU. Other part is OBS, Google, some role. Okay, that's enough to listen. Okay, everyone, that's all. If I will make some other project, I will share with you guys.